Hi, I'm Darian. I'm the chassis CDT captain. Hence the reason why I wrote it right there. Chassis is spelled with an I-S, not a Y. So this is my chassis presentation. Okay, so a chassis. You've probably heard the word before. It's basically the term for a lot of things. There's computer chassis, there's car chassis, there's robot chassis. So our robot is over there. It's also right there. That is the robot from 2010. And you can see from the outside, this is the chassis. It's all kind of, one thing. It's like, car chassis. That's my analogy. So, and a computer chassis, it houses everything. So, robot chassis does the same thing. The chassis CDT has to work very, very closely with every other component design team to make sure everything fits and fits well inside of the chassis. Okay, what makes a good chassis? It has to be lightweight, rigid, open to modifying and tweaking because there's always an extra hole to drill. It has to be durable. It has to be relatively easy to assemble and maintain. And lastly, aesthetically appealing. Mitchell doesn't like aesthetically appealing things, so ignore him. Continue. Okay, so these are some common materials used in F.R.S.T robots. So picking out a feasible, light, rigid, durable, quick to build material. There are some pretty not feasible ones that I've seen. There's carbon fiber and fiberglass, but they go away. And click again, I forgot the rest of it. And yeah, wood, we don't use wood. Kitbot's boring, steel's too heavy, welded aluminum's too difficult to build. So, the obvious polycarbonate. So, we are the only team in F.R.S.T to use a plastic polycarbonate chassis. Polycarbonate is a very flexible, very durable plastic, oftentimes called Lexan, etc., etc. Continue. So, why do we do polycarbonate if no one else does? Here's the pros and cons. Pros: it's durable, it's very flexible, very durable. It's clear. It's relatively easy to manipulate, so it's not too hard of a material to get used to. We have a lot of experience with Mr. Whitman. He owns this shop. He's been working with it for years upon years upon years. Resources, same thing. We're in this shop. Uncommon: it turns a lot of heads at competitions. People are pretty amazed when they find out there's no underlying structure that's all built out of polycarbonate. Cons: it is flexible, so that can be either advantageous or not advantageous depending on the game. So it's also relatively heavy to get any sort of rigidness out of it. And it's uncommon, so finding resources on robot polycarbonate chassis building, it's not too common. So, continue. So here's the little build process. It's relatively quick, I hope. The first step, it's brainstorming. This is, Kyle talked about it a little bit, to where we come up, we write on the whiteboards like, here, this is how we're going to make the robot work. Most of the time, though, people don't talk about the chassis when we brainstorm, and they just draw a box to represent a robot. You will see that, I promise. The sketches, they also go inside your engineering notebook. If you want your idea to be taken seriously, you want a good representation of it, and the best way to do that is put it in your notebook and show it to me and other people later. Second, research, see what other people have done, see what we've done in the past. A lot of the research you're going to be doing isn't going to be, Google. It's going to be coming up to me or people who have been on this team for a little while and asking, okay, what's going to work better, this, that, the other thing. Dimensioning, we need to figure out how big this can be and how tall it needs to be, etc., etc. Getting some spatial relations type things, and then figuring out a basic shape. That's also where we need to communicate with all the other component design teams to find what needs to go where and how this chassis should start taking shape. The second step, we jump into CAD. We use Autodesk Inventor. I recommend anyone who's doing anything mechanical to get it, because it's free. I'm not kidding. It's a fantastic program. It intensive. You learn a lot from it, and it's very helpful on this team. We don't use it enough. It's very helpful. Chassis uses it though, mostly to estimate the weight of the robot, to find spatial relations. Hopefully this year, I've been working with this a little bit, is do some stress testing. And then lastly, it's actually what we use to get our final designs cut on the CNC. Third step. Yep. That's cutting. We actually don't cut these pieces by hand most of the time. There are always a few little handmade pieces thrown in there. The pieces are actually cut on a computer numerically controlled mill out there. It's on a big table, cuts 4x8 sheets of polycarbonate. The reason why we use it is because it's accurate and it allows for very intricate designs. So we can go pretty crazy with what we do stuff now, or with how we do stuff. Some of the techniques we use in this cutting process, we can pocket the sides of the chassis, which I'd show you if I should have put a picture. I didn't put a picture. Which is where we cut a little way through the material, but not all the way, so it maintains a lot of the structure, but it also reduces a lot of weight. So you can cut off about, last year I think I cut out 7 pounds from the pocketing alone. Lastly, we can do electronic placement really precisely. This is off and on. A lot of times electronics have to move or whatever, so that can get all cut out on the CNC. Really cool stuff.
Did you want to show the vendor drawing?
There's another one. And then when everything gets cut, we start working on the assembly and some hand fabrication. Drilling, you're going to get trained on every single tool you use here, whether it be a hand drill, whatever. Drilling always requires 2 people at least. If you're using a drill press, you're going to be drilling straight because it's on a drill press, but you're going to need a spotter because of safety. It's very important. And if you're drilling by hand, still a spotter for safety, as well as someone telling you if you're level or not. And once again, just double check everything 5 times. And then most of the time we have a very square chassis, it's very rectangular. So you have to square up the chassis, otherwise other things won't line up later and it screws everything up. So we always use squares. Tapping, which might be a new word to some of you. Tapping is actually the process of cutting threads into material. So that's what makes a screw able to screw into something. We do all of the tapping here by hand. It's very time consuming and yeah. And sometimes we have to bend stuff. We use the apron brake out there. Once again, that's a tool that you're going to get trained on. You're going to be using a lot of tools in the chassis. You're going to be using the mill, drill press, bandsaw, hand drills, taps, etc., etc., etc. Next slide, please. What you'll learn and do. Communication is a huge one. Chassis, like I said, is probably the most, people rely on us the most to get everything fitted inside the robot the way it should be. So you really need to talk to electronics, manipulator. We work really closely with drivetrain, because normally drivetrain is pretty well implemented inside the chassis. You're going to learn Inventor whether you like it or not, I don't care. It's very helpful and it's just a fantastic program. Drilling, tapping, that just goes into the general workshop and practice and skills. You're going to learn teamwork because that's what this is all about. So, next slide. Any questions? At all about anything?
Is that a robot?
That's not a robot, that's actually my automobile. So, no questions?
Okay.
No questions? Oh, yes.
So, since the chassis basically has to incorporate, well, not basically, it has to incorporate every single physical aspect of the robot, how do you manage to work, you know, there's other CDTs, how do you manage to get everything in there and determine where it's all going to go? In other words, is time your most critical factor here?
This is actually,
or is it like you decide this is what our chassis is going to be, everybody else, you got to make it work in here?
This is going to answer Mitchell's question, which is what's going to be the hardest thing that you have to overcome. The hardest thing you have to overcome when you're doing this is waiting for the other CDTs to give you shapes, dimensions, and what they need to go where. Because like I said, this is all cut out on a computer. better. So it's best, we're gonna have a more accurate, a better looking robot if we can get everything precision cut, instead of kind of hacking away at it later. So to get it precision cut, it needs to be on this model, which is, I worked on this. This is what I do a lot of. So yeah, that's the most difficult thing. Do you have a question, Mitchell?
How is chassis going to improve for this upcoming build season?
Chassis has been thinking a lot about how it's going to improve, and Chassis decided that we're going to do a lot more intensive design prior to CAD work. We're going to do a lot of stress testing, hopefully, inside of CAD, as well as just maybe a little bit more extreme design here and there. You never know. Any more questions? No? Okay. And this is the Inventor model. I'm just going to go through this quickly. You can actually change materials on Inventor, so you can put polycarbonate to you can set it to a polycarbonate to where it'll show you all of the material properties of it, like density, weight, how it deflects under pressure, etc., etc., etc. You can make assemblies like this, and yeah. So it's pretty sweet. It's a free download for students. So when you go home, start the download because it takes like 6 hours. So yeah, that's all I have to say. No more questions, and yeah.
I'm gonna just follow up from that. You have to be a team member on Stims before you can get that software done.
I was not, and I still got it, but I don't know how.
Did you get the 30-day trial?
No.
You just have to tell them you go to a high school.
Yeah.
Oh,
They don't even verify it. You can lie to
Yeah.
them if you want.
It's kind of
That's
sad.
that's not doing it.
But we're an honest team, and we all go to high school here. So
Yes, we do.
Is it on the Autodesk website?
it is on the Autodesk education website.